Three charges lie along the x-axis. One positive charge is Q1, 15 microcoulombs, and it's located at 2 meters. Another positive charge, Q2, is equal to 6 microcoulombs and is located at the origin. The problem says three charges, okay? Three charges. There's missing one charge, okay? So, at what point on the x-axis must a negative charge, Q3, be placed so that the resultant force on it is 0? So, I need to find at what point. When it says at what point, it refers to in which position, okay? In which position on the x-axis I should place the charge Q3 so the resultant force on it is 0. So for that, let me show you two more things, okay? Let me show you two more things. First of all, the problem here is not giving you a sketch. You have to do it. So we're going to focus on the axis. It says that the three charges lie along the x-axis, okay? So I will locate an x-axis first of all, okay? It's gonna be right here. So for an x-axis, I will need to place the origin, which is my point 0, and I need to place the position 2. And why the position 2? Because those are the two positions that are indicated here in the word problem. It says that one charge is at the origin and the other one is at x equals 2 meters, okay? So I say that this is 1 meter and this is 2 meters, okay? So at 0, we call it the origin. In the origin, I know I have the charge Q2, okay? So I'm going to place my charge Q2 over there. And this charge Q2 is equal to 6 microcoulombs. Okay, now in the other side, I have the Q1. Q1, it says that is 15 microcoulombs and is located at x equals 2 meters. So, take a look. That's what I have, okay? The two charges, one at 0 and the other at 2. Now imagine that the problem doesn't say 2, that the problem says that it's located at negative 2 meters. So where would you place a charge?
In the other side, when is the negative?
Exactly, in the other side, where is the negative? In this, okay? At that place, in here. So it is important that we follow that we read the problem carefully and then we place the charge exactly where it says, okay? So I have the two charges. Now, do I know the position of Q3? Do I know the position of Q3? It says, at what point on the x-axis must a negative charge Q3 be placed so the resultant on it is 0? In Spanish, ¿en qué punto del eje X tengo que ubicar la carga negativa Q3 para que la resultante sobre ella sea 0. The question is very difficult to understand, but we're going to focus on the beginning of the question, the part that says, at what point? At what point refers to position. In which position is Q3? Eso es lo que yo estoy buscando. Where is located Q3? Entonces, yo no sé dónde está Q3. I will put it at a random place. Let's say that I put it here. Let's say that I put it there. I don't know where it is located. I need to find it. Now, what do I know about the sketch? What do I know about the sketch? I know
That Q3 is say that it's negative, so will be in the other side.
yes and no. Yes, it's negative, a negative charge. It is very important that it's negative. But the charge is negative, not the position. These charges are positive, okay? You're going to see what that means later. But it doesn't mean that it's located in the negative part. Now, I'm going to show you something. I need to locate information in this sketch. So for that, I'm going to write more information. What distance I have here? What distance I have here?
$2.
2 meters. That is very important. Thank you. So I'm saying that all these measures 2 meters, okay? I'm saying that the distance between these two charges is 2 meters. And I'm also saying that Q3 is inside those 2 meters. That's very important. Now for this kind of problems, we're going to use algebra to solve it. Here there's not much physics but algebra, okay? So I know the whole distance here is 2 meters. That is very important. Now, remember what we're looking for. We're looking for the distance at which Q3 is going to be placed. ¿Ok? Yo estoy buscando la distancia en donde voy a ubicar Q3. Yo la puse ahí like randomly. O sea, sin saber que ahí está, ahí la puse. ¿Ok? It's just a personal choice. It doesn't mean that it's really there. It's just a reference. Entonces, because I don't know where Q3 is located, I will say that Q3 is located at a distance D from the origin. Yo voy a decir, que como yo no sé dónde está ubicado, yo digo que está a incógnita distancia. And I will call the distance D. And this distance right here, between Q3 and Q2, I don't know it neither, okay? But if I use another variable, it's going to be too complex. Entonces, tratemos de usar una sola variable. If we are using D, let's try to use D also right here. I know that this is a total distance of 2. I know that this is D, okay? Now, I will show you a similar situation. Imagine that this is 2, that this is X, Imagine that. Sorry, not x. Imagine that this is 0.5, and I want to know what is this distance. How can I get that distance? The formula, what would it be?
We can subtract the 2 and 0.5 and know what is the variable missing.
Okay, we can say that 2 minus 0.5 is the missing space, okay? Now, imagine that instead of 0.5, I have a letter D. So how can we get that distance? Instead of 0.5, I have D. So the formula is not 2 minus 0.5. Now it has changed to 2 minus D. This is the exact situation that we have in this problem. We have a total distance of 2 meters, and we have a value that we don't know yet, but we call it D. So the rest of the distance, which is this one, I can call it 2 minus D. That's a way to get it. Now, we're going to focus in this moment on the kind of forces that we have between the charges. Okay, so I have Q3 right here. I have Q2 right here. And I have Q1 right here. This is a negative charge. This is a positive charge, like this. Sorry, you're not seeing. This is what I have, okay? This is what I have. So what kind of force is going to be exerted between Q3 and Q2? Between them, what kind of force is going to be exerted? Attraction or repulsion?
Attraction.
Attraction. So they want to be together, okay? They want to be together. So the attraction force is going to be like this, okay? And I will call this force 2, 3, because it's coming from the particle 2 to the particle 3, okay? Now, between these two charges, what kind of force is going to be exerted? Attraction or repulsion?
Attraction.
Also attraction, okay? So these charges want to be together. Now, this force, I will call it F, and that is Q1, okay? So this is going to be F1, 3. And now my sketch is done, okay? So this is the situation that I have for this problem. Now, see the topic. The topic is called equilibrium. Equilibrium means that the forces are going to be balanced, okay? That is where equilibrium happens. Now, let me show you something before I continue. Let me show you something. Let me show you two situations. Okay. Imagine that you have to do the chart for the problem A. Okay, we're working just in the chart of the problem A. So you have your vectors, your x and your y. Okay, the vector 1 goes up and the vector 2 goes down because they are just vertical. The x is going to be 0 for both, and for y this is going to be 10 and this is going to be negative 10. So when you add all the components, you will have 0 here and 0 there. In total, the resultant is going to be 0. That happens because the forces are exactly the same and they are pointing out to opposite directions. Now, let's talk about situation B. If you do the sketch for B, I mean the table of components, for B you will have your vectors x and y, vector here and vector there. In y is going to be 0 because those are just horizontal vectors. In x is going to be 10 the first and negative 10 the second. When you add them all, you will have 0 and 0, and the resultant will also be 0. Are we agree on this? Do we agree on this? Sorry. Yes, right. So, in other words, for equilibrium to occur, I need the forces to be the same and the forces to be in opposite direction. These forces here, they are going in opposite direction, but because I want them to be in equilibrium, they need to be the same. And for the forces to be the same, I will say that F2, 3 must be equal to the force 1, 3. That must be accomplished. Okay? To find the equilibrium of all these need to be accomplished. The direction of the forces are opposite and the forces, they need to be the same. I'm going to delete this. And now it's where the topic begins. That is just the introduction, okay? So, according to Coulomb's law, the electric force is calculated as Kc times charge 2, charge 3, okay? Charge 2, charge 3, divided by the distance between 2 and 3 raised to the second power. This is going to be equal to F13. That is going to be calculated with Kc Q1 Q3 divided by the distance between 1 and 3 to the second power. Now, look at what we have, okay? We have this large equation, but we're going to reduce it. As you know, in chemistry, when you have 10 electrons in the reactants and 10 electrons in the product, they are cancelled. We cancel them because they are the same, and they are doing the same operation. If you have 10 water in the reactant and you have 10 water in the product, they are also going to be cancelled because we have the same value in the two sides of the equation. Here we're going to do the same. We're going to cancel those values that are the same and they are doing exactly the same mathematical operation. For example, Kc and Kc in the two sides is multiplying. I know that it's multiplying because it's above the division sign, okay? So because they are both doing the same and the value is the same, they are going to be cancelled. Again, it happens the same with Q3. Q3 is a value that we don't know because it's not given in the problem. But it's the same variable. That means that it had the same value. And again, the two of them are above. That means that they are multiplying because they are the same value and they are doing the same mathematical operation, they are also going to be cancelled. And now the equation is being reduced. Now the equation is Q2 over R23 to the second power equals Q1 divided by R13 to the second power. Now, we don't know these distances, okay? So we're going to gather them from the sketch. Right now, I will focus on R23, okay? R23. Let's see. Here we have the sketch, okay? So the distance between Q2 and Q3 is this one. This is the distance. What is this distance? Do we have a value for it? Do we have a number? Do we have a letter?
Yes, we have the letter D.
We have the letter D. Okay, so between Q2 and Q3, this is the distance. Okay, and the distance, as you said, is the letter D. So R23 is equal to D. Okay, now let's focus with R13. Okay, 13. Again, I go back to the sketch and I look for the distance between Q2 and Q3. Sorry, that is Q1. So what is the distance between them? What is the distance between them?
2.
2 is all the distance. 2 is all this distance, but I'm looking just for the distance between the charges, this little portion. How much does it measure?
2 minus D.
2 minus D. Okay, I take this distance from here to here, and this portion measures 2 minus D. So the distance between 1 and 3 is 2 minus D. Don't get lost in this part. So now I'm going to arrange this equation with the data I have. I have Q2, that is 6 times 10 to the negative 6 microcoulombs, divided by R23, which is D, that is raised to the second power. In the other side, I have Q1, that is 15, I guess. Yes, 15 microcoulombs. And because it's micro, I just do the conversion here. Sorry, these are just coulombs, not microcoulombs, because it's already converted. Okay? And all this is divided by R13, that is 2 minus D. That must be raised to the second power. Don't get lost in this part. Okay? So, right now, I'm going to leave the green part in one side and the blue part in the other side. To do that, I will cross multiply. This one is multiplying, so it goes to the other side, to the bottom. And the one that is in the bottom goes in the other side to the top. So you will have 2 minus D squared divided by D squared is going to be equal to 15 times 10 to the negative 6 coulombs divided by 6 times 10 to the negative 6 coulombs. Okay? Now take a look to what I'm going to do. Here I can cancel the units coulombs, but I'm a lazy person. I see that this part, that the exponential part of the scientific notation is the same, okay? So I'm a lazy person. I'm also gonna cancel it because it is the same. Take a look. I'm making your life simpler, okay? So I say that 2 minus d squared over d squared is equal to 15 over 6. How much is this?
2.5.
How much is 15 divided by 6?
2.5.
2.5. Okay, so take a look. Because here I have my variable raised to the second power, I need to get rid of it. To do so, what I need to do is I need to get square root, but because it is an equation, I will do it in the two sides. So in the end, this will be 2 minus d divided by d, because I cancel the square from the top with the square, and the square from the bottom also with the square. Now, how much is the square root of 2.5?
1.58.
1.58. Okay, now I need to isolate for d, okay? But d is in the top and d is in the bottom, okay? So right now I'm going to go back. I will change the position of this d. I will send it to the other side. It is dividing, it goes to multiply. So you will have 2 minus d is equal to 1.58 multiplied times d, okay? Or just 1.58 d. And this should be in one side because it needs to be isolated. So you say 2 is equal to 1.58 d. Now, this d right here was doing a subtraction. So when it goes to the other side, it goes doing an addition. So now you will have 1.5d plus d, okay? Remember, when you don't see the coefficient, it's invisible 1. So you continue, you say 2 is equal to 1.58 plus 1 will give you 2.58 d. This is what we know as like terms, okay? We have the same variable and it's been added. So we have 2.58 d. Now my d is just one variable, okay? Here I had 2, but now it's been reduced to 1. And this value right here is multiplying. So it needs to be sent to the other side. It is multiplying, so in the other side will be sent to divide. So you have 2 divided by 2.5 is equal to d. How much is d?
0.77.
Here is 2.58, sorry, I missed the 8. How much is this?
0.78.
77.5. You can round it to 8, okay? So So D is equal to 0.78 rounded. And this, of course, should be in meters. Now, what is this? What is this? It's not just an answer and that's it. So I'm taking my origin and my initial sketch, and I will put this information here. I know that D now it has a value that is 0.78 meters. Okay. Now 2 minus D, it is how much?
1.22.
1.22 meters. So for the charge, the negative charge Q3 must be placed at 0.78 meters from the origin, so the two forces are equal, that they can be cancelled, and the resultant gives you 0